Practical problem solving for oblique and right triangle problems. We're going to try a problem that uses several of your triangle skills in combination. Let me read you the example. Steve and Jan wanted to try out their trigonometry skills. They were vacationing in the mountains in a house on top of a cliff. They wanted to know the height of the cliff and the width of the river at the base of the cliff. They took a point by the riverbank and from their window measured the angle at 63 degrees 10 minutes. They went to the base of the house, which was 25 feet lower, and measured the angle at 68 degrees and 15 minutes. What is the width of the river and the height of the cliff? Round your answers to one decimal place. We've drawn a diagram of this problem. Here's the house that Steve and Jan were staying in, with point C being the original point that they measured from, and point B being the bottom of the house, which is 25 feet below. They looked at a point across a river, this point A over here, and they measured the angle from C to A, and then they also measured from the bottom of the house what kind of an angle did it make. They know a measurement for C, they know it's 63 degrees and 10 minutes, and they know a measurement for D, which is 68 degrees and 15 minutes. And they want to find out some information about the height of the cliff and the width of the river. Now, if I look at the height of the cliff and the width of the river, it makes a nice right triangle along with their line of sight from the bottom of the house. Unfortunately, I don't know anything about that triangle. So what I'm going to have to do instead is work in the above triangle, in the oblique triangle, and try and find out some information. Specifically, I'd like to know the distance from A to D. Now, before I can do that, I need to know something more about the angles in that particular problem. I only know one angle and one side so far. We know that angle C equals 63 degrees and 10 minutes, and we do know that angle D equals 68 degrees and 15 minutes. Using this piece of information, we'll be able to find angle B, because we know that angle D and angle B together make a total of 180 degrees since they form a straight line. So in other words, I know if I want to find angle B, I'm going to take 180 degrees minus 68 degrees and 15 minutes. When I do that, I find out that angle B is 111 degrees and 45 minutes. In this oblique triangle, since I know two of the angles, I'll be able to find the third angle, because I know that angle A plus angle B plus angle C should total 180 degrees. So I'll have A plus B plus C equaling 180 degrees. I don't know angle A, that's the angle that I'm trying to find. Angle B we just found to be 111 degrees and 45 minutes. And finally, angle C we knew was 63 degrees and 10 minutes. And I know that those angles should total 180 degrees. When I total these angles, I have angle A plus 174 degrees and 55 minutes equals 180 degrees. And I can find out that angle A is equal to 5 degrees and 5 minutes. Now that I know all three angles in this triangle, it will be easy for me to solve for one of the missing sides. The side that I'm going to be most interested in is going to be the side that goes from A to B, since that works as the hypotenuse of this lower right-hand triangle. You can see I've drawn the upper triangle to the right of my diagram. I know lots of things about this triangle now. I know the length of this side, of side CB, because I know it's 25 feet, the height of the building. So I can put 25 there. I've already found what angle A is. Angle A is 5 degrees and 5 minutes. Now I'm glad to have found that angle and that side, because I know I can use the law of sines by setting up a proportion between that angle and that side. We can find either of the other two sides, but the one we're most interested in is the side between A and B, because that will serve as the hypotenuse of this right triangle. We really want to be able to find this side. Since this is the capital letter C, we'll let little c denote that side. We want to know the angle opposite that side, and we have found that angle C is equal to 63 degrees and 10 minutes. Using this information, we're going to solve for C, the missing side of the triangle that we want to work with. I'm going to use the law of sines by setting up a proportion between this side and the angle opposite that side. So I'll have 25 over the sine of 5 degrees and 5 minutes. Now C is the side that I want to find, so I'm going to be concerned with the angle opposite C, and I'm going to say C over the sine of 63 degrees and 10 minutes. So I've set up a proportion which I'm easily able to solve using the law of sines. I need to solve this equation by getting rid of the thing that C is divided by. So I'll multiply both sides of this equation by the sine of 63 degrees and 10 minutes. When I do this on the right-hand side, they will cancel out. leaving me with only c, which is exactly what I want to find. I have c is equal to the sine of 63 degrees in 10 minutes times 25 over the sine of 5 degrees in 5 minutes. I'm going to do this problem on my calculator, so I'll move to the calculator. I'm going to find the sine of 63 degrees in 10 minutes, but first I need to change it to a decimal, so I'll put in 63 degrees and 10 minutes and change it to a decimal, and I'll find the sine of that. I'm going to multiply that amount by 25, and then I'll divide that by the sine of 5 degrees in 5 minutes. So I'll put in 5 degrees in 5 minutes, change it to degree decimal, take the sine of it, and then I'll complete by hitting the equals key. I get 251.77 for c. c is equal to 251.77 feet. Once I know that, I can go ahead and solve the remainder of my problem. If I look in the problem, I see that this length has now been determined to be 251.77 feet. You'll notice that this bottom line, C, in the oblique triangle, serves as the hypotenuse in the right triangle. So I know the hypotenuse of the right triangle is 251.77 feet. Since this is a right triangle, I can use stuff that I learned about a right triangle some time ago to help me solve the problem. I'm going to discern what the length of DE is, and that will represent the height of the cliff. I'm also going to find the width of the river in the triangle, that would be FE. If I want to find these particular things, I also need to know an angle. I know that angle D is 68 degrees and 15 minutes. And I'm going to use the trigonometric features of a right triangle to help me solve this particular problem. If I want to find DE, I see that DE is the side adjacent to that angle. I also know the hypotenuse. And I know that the cosine of an angle, the cosine of 68 degrees and 15 minutes, is equal to the side adjacent to that angle, which I do not know, we'll call that little f, over the hypotenuse, 251.77. I know I need to cross multiply to solve this problem, so I'll have 251.77 times the cosine of 68 degrees and 15 minutes equaling f. I'm going to do this problem on my calculator, and I'll enter 251.77 times, I'm going to put in 68 degrees and 15 minutes, so I'll have 68 degrees and 15 minutes, change it to decimal degrees, and take the cosine, complete the multiplication by hitting the equal sign. So after our calculations, we see that f is 93.30 feet. So we found f, the height of the cliff. F corresponded to the height of the cliff in our drawing. So we found the height of the cliff to be 93.30 feet, and now we want to work on finding the width of the river. The width of the river corresponds to D in our drawing. It's the side opposite angle D. Now we know from trigonometry we can solve this problem very easily. We're in a right triangle, it's okay. If we look at D, it's opposite this angle, so I know that I want to use sine. I know the sine of 68 degrees and 15 minutes is equal to D, the opposite, over the hypotenuse, 251.77. I know that I'm going to cross multiply so that I can get D by itself, and I'll have 251.77 times the sine of 68 degrees and 15 minutes is equal to D. So I'm going to come to my calculator, and I'm going to make sure to clear it out. I'll put in 251.77 times the sine of 68 degrees and 15 minutes, so I'll put in 68 degrees and 15 minutes, changing it to a decimal, and I'll take the sine and complete the operation by hitting the equals key. And I have 233.85 feet. So I know D is 233.85 feet. I'll remember that D was the bottom of the right triangle, which corresponds to the width of the river. So using our trigonometry skills, we were able to find the height of the cliff and the width of the river without using any direct measurements of those things. In this problem, we had to use several steps for a solution. We had to use what we knew about the angles in a triangle to find out all the missing angles. We had to use the law of sines to find the side that we needed that functioned as a side in both the oblique and the right triangles. And finally, we had to use what we knew about right triangles to solve for the missing sides of the height of the cliff and the width of the river. When you combine all of your trigonometry skills and what you know about triangles, you'll be able to solve very complicated multi-step problems by just having a good plan and following what you know about trigonometry.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.